welcome to Trusting AI to Modernize Software at Scale. In this talk, I'll take you through our experiences at Moderne and in working with Generative AI as a company that aims to make reliable code changes at scale. That might then seem like a bit of a contradiction to use Generative AI, but we're going to see how we've actually made that work. I hope that you'll learn from our pragmatic approach of using Generative AI, how you can maybe leverage this technology in your own work as well. And we'll be doing this as a bit of speed run today, because as always, the good stuff is near the end. And I know that this is the very last slot. So first up, this is me, Tim de Beek. I'm a solutions engineering manager at Moderne. Among many other things I do there, I'm also the community lead for OpenRewrite. I'm a big fan of contributing to open source software, as you can see for the big green bar over there. And once in a while, I'll do presentations like this one. And perhaps good to call out today is that I'm very much not an expert at AI at all. But that's a good thing about working at Moderne, is that I get to work with folks a lot smarter than me. So as you can see here, I have some colleagues who've written a book on leveraging AI precisely for the topic, which is perfect for me when you want to prepare for your presentation, that you have a book to go and read. Now, we had a colleague working at the Mila Institute in Montreal who, together with other AI researchers there, helped bring groundbreaking AI work to Moderne for use of our users as well as our customers. We'll be taking you through some of what we've done there. So, like I said, I work at Moderne, which, if you're unfamiliar, Moderne is the main sponsor of OpenRewrite. It's a commercial platform where you can go to help maintain your code. It's a place where folks on a platform team are able to find automated rules-based recipes to modernize their software, to mass commit code fixes, and do upgrades, security patches, things like that. So we offer this for free to open source software, and also we offer this to our customers as well. Now, and if you haven't heard of OpenRewrite before, then I invite you to twist your head a bit, because the logos are very similar. It's just the same one, 90 degrees turned. Still, I have to explain this a bit. So OpenRewrite is a safe code refactoring framework. It's mostly written in Java, but it's reusable across a range of other languages as well. It allows you to automate the boring parts of code maintenance, reducing technical debt, improving code quality and security. There's some 4,200 recipes available today for use cases in Java, TypeScript, and C#, with Python coming up as well. Now, OpenRewrite is open source. It's Apache licensed. There's plugins available for you to run it as part of your build, but then you can only upgrade one project at a time. You can go to GitHub. You can figure out how all of this is implemented with parsers and compilers, and then building up a model that you can manipulate for the changes that you're after. But we also see this increasingly integrated into other tools. So if you are using IntelliJ Ultimate, you'll find an integration with OpenRewrite already installed on your machine. If you're using Amazon Q, underneath that is just OpenRewrite again. And the same for GitHub Copilot Upgrade Assistant for Java. That is also just using OpenRewrite with some AI sprinkled on top. So if you've never heard of OpenRewrite or Moderne before, then congratulations. That's already a big boost for you today. But you've also not been paying attention, because we've been doing this for 10 years. So I've been telling folks a lot that this is a thing you can do, and that then helps you automate some of those boring stuff that you probably have wrestled with yourself. I always like to use, this is a bit of an example that really care about the details here, but every time you upgrade a library or a framework version, you'll probably have to make some silly code changes. They decided that you have to rename a method, you rename a class, you change some arguments, or in this case, move something from an annotation to a new method invocation, and that's what you have to do. Which, in isolation, if you just look at the single one, isn't too bad. But if you have a couple thousand of these, then quite quickly this becomes very boring to do. And also, if you look at the type of change that you need here, it's not very trivial to do this with a regular expression, because you have to match the thing and move the thing and move. It's just not going to work very well. The reason that we're able to do this is because we build up a very detailed model of your code. We've called that model a lossless semantic tree. It's similar to an abstract syntax tree, but then heavily enriched with additional data that we need to be able to make these reliable code changes. So when you look at the model on the left, we've enriched that with type information, showing you exactly what the underlying types are and how they're being used, and also all the formatting, because a lot of the times the first thing a parser does is throw away all your comments and all your formatting, and then good luck making any kind of code changes automatically. Now, once we've built up that model, we traverse that model with the visitor pattern. That allows us to inspect any kind of elements of that LST model that we have, and then make modifications to write it out exactly as you want it. Maybe that's renaming that method, that class, that variable, or moving that thing from an annotation to just a new method invocation, but it can be really anything that you want. Now, this model we found is unique to what we do. It underpins everything that we do at Moderne, but we also found that this is a model that should benefit everyone. So we've open sourced this model. It's a Apache license, everyone can use it. And like you saw, Copilot, Amazon Q, and IntelliJ are all using this model as well. Now what we then do at Moderne is that we run these recipes at scale for the wider open source community and our customers to help them maintain millions of lines of code. Now, I'm not telling you this as part of an advertisement. I'm telling you this to give the context of how we're using AI. Because if you have a couple million lines of code, then you probably want reliable code changes. When you run a recipe and you see an automated code change, it should just work. It shouldn't work in 99% of the cases, or 99.9.99 something. It should all just really work each and every time that you run it. So that means there is a lot of trust involved. When we make code changes, they should be exactly what you want. Such you could, in theory, review every line of code, but you really shouldn't have to review every line of code, because it is rules-based transformations that we do. Now, our customers, they are typically very large financial institutions. The big banks, big insurers, those kinds of companies that have a lot of code to maintain and don't necessarily have either the resources to be able to make sense of it all. And what's interesting for this particular use case is that we found that they either love generative AI or they absolutely hate it and want it turned off the moment that you tell them about it. So that then makes it a challenge for us when building out these capabilities that we have to always support both models. We've had potential customers come to us who would love Moderne, but they only had budget for AI. So then you kind of like have to do something to sell them, well, we're rules-based, but you can leverage AI in some way. And others, like I said, they want it turned off the moment that they see it. So interesting mix. Now let's see in that context how we can still get value from something that is inherently unpredictable to something that our users actually love working with. And ideally, we want to do so without massive expense, because we are a startup and we're competing with some of the largest companies in the world, which is, again, a very interesting dynamic there. Now I'll take you through our experiences working with AI, and I'll show how that has pretty much followed the hype cycle. Now, you've likely seen this trend before, where whenever something new comes out, initially things get weird for a small bit. At the very top of the page, you can see there's like blockchain for cat food, which is something that I just thought of. I sort of typed it into Google, and you could actually find a blog post with someone who thought that blockchain for cat food was a perfectly good idea. If you now type AI for cat food, you're going to get a lot of generated recipes for cat food generated through AI. It's just every trend has the same cycle of inflated expectations and then a trough of disillusionment before reaching finally the plateau of productivity. So keep that in mind as we go through. This is kind of what you're going to see. So when OpenAI and ChatGPT first became available, we had high hopes. That hype cycle, way at the top. We had some 1,000 recipes back then, and we've since quadrupled that number. All of them small automated rules you can apply to your code to do some code modifications. But still, even if we have to 4,000 today, there's a lot more ecosystem that we have to cover. Previously, folks were amazed that we were able to cover any part of their code migrations at all. These days, we get complaints that we're not out of the box converting their in-house queuing library for Amazon AWS at all out of the box already. So very interesting shift there. So we set out to generate recipes to be able to close that gap in code coverage that we have for recipes. So we had our AI researcher, Justine, at the time. She trained a model. She had the model write some recipes based on the examples that we had, and it looked pretty convincing. at least to Justine, but then she asked a colleague to have a look, and some very clear problems occurred. First off, the whole thing didn't even compile, which isn't great if you're writing code that you want to execute on a large scale. But then it was using a lot of methods that didn't even exist at all. So again, not great when you're writing code that it does that. And then all of our recipes, they kind of use the visitor pattern, traversing that tree that we have of your code, and it had no sense of doing so either. So clearly, that is quite challenging when you want to write a recipe, that you just get something that doesn't in the furthest look like something you can actually use. So we had to drastically scale back our expectations there. So then we said, well, what can we be doing on a smaller scale? And for that, we used this example of a recipe we already had, but which we thought would maybe be a good one to hand off to an AI to make improvements here. And it's based on a check-style sonar type of finding, where if you have a switch statement, they'd like you to use the default case last, just for readability, to be a bit more consistent in how they have that. So on the left, you have a couple of things not compliant. On the right is the compliant solution. And now let's see how we can actually hand this off to AI. So in this case, doesn't really matter the entire implementation here, but in general, what you'll have is that we have that visitor, which we have. You override one visit method to visit a switch. If in that entire switch we find a default case, then we hand the entire switch over to AI with the instruction that you see on line 58. Write this switch statement with the default case last. I would absolutely love it if all our recipes were this easy. Find the element you're interested in, hand the whole thing off with a bit of instruction, and then see what you get back and insert it back into the code. Now, the interesting is that if you run it, it actually does work. Some of the time, but if you run it again, then you might get a different result, which isn't great. And if you run it 100 times, then you are definitely in trouble. So this isn't great. If you've seen this one ever, then definitely recommend. And I can also show you this in a quick demo. If the tech actually works with me today a bit, let's see if I can mirror my screens. So we have my IDE, we have this one, we go and enter presentation mode. Come on. Is this readable a bit? Yeah. It's the exact same visitor that we had before, where we visit a switch, we find the default case. If it's there, then we hand it off to a generative code editor. Now this one is very simple as well. It's just an HTTP client that ships it off to OpenAI in this case, with the instructions to, here's a text block, do the thing that I tell you to do with it, and then hand it back to me, and we'll insert it back in. Now for honesty, I'm going to say we're going to use GPT-4o today, which admittedly isn't great, but I think the results will definitely translate to other more recent models as well. And then let's have a look at the tests that we have. So for every recipe that we also have tests to verify that it does exactly what we expect it to do. Because like I said, our customers, they like predictability, so we give it one input like this one, a switch statement which admittedly doesn't have the default case last, should be turned into having the default case last there. So this is one of the type of test that we have. But we have another type where we say, well, if you already have a switch with the default case last, you shouldn't be doing everything at all. So with that out of the way, let's run these tests and see some of the changes that we get when running this through OpenAI's GPT-4o. Now, I'll skip through the ones with the no change expected first, and first look at the ones where we expect the default case to be moved to the last one, and we'll explore some of the changes that we see there. I've already helped it a bit by doing something that is quite odd, where if you ask it to move the default case last, and you have a case 2 here, and then you'll see that it expects, in this case, to move both the default and the case 2 to the end, but it also inserts the same body that you had for the default fall through here as well, which ideally it shouldn't, because you have a fall through here. But we're going to tolerate that it does this because it just helps speed up the demo quite a bit. So with that, we're going to see how well it does. We're doing 20 repetitions, and we can see that already the first one isn't what we were hoping for. So let's see some of the changes. In this case, it's leaving the case 2 at the original position, which is already better than I had anticipated, but it doesn't do so on the second iteration, or the third, or the fourth, or the fifth. So clearly already just running it for 5 times, you're gonna get different results. And let me reiterate again, our customers, they have millions of lines of code. They probably have thousands, if not tens of thousands of switch statements. They definitely don't want to have to review every switch statement that has been reordered. And then if you run it again tomorrow, then your 5th repetition is gonna shuffle them again, which isn't great. And then even worse still, for the cases where we expect no changes at all, it can't really help itself. It's like an intern that wants to be useful, and it's just going to do things that we don't quite expect or desire it to do. So in this case, it shouldn't have done anything at all, but I figured I'll just add some comments because you asked me to do something to this code, which, like I said, isn't very helpful. It's actually hurting when you actually want to have to review this code. The second one is even more interesting because we get an exception because it didn't give us the response that we expected and told us to give back. So we actually get a whole bunch of plain text inserted into our code. Also not great. And then the third one, again, it shouldn't be doing anything at all. And what has it done? It's done a different type of comment than it did on the previous iteration. So clearly, this isn't really fit to run at scale. So we kind of backed out of this approach because as much as I would like all of our recipes to be that one-line instruction, it's definitely not going to help well when you run this on a larger scale. So let's try to switch back to the presentation. Join this place. Yeah. So we have this. As you saw, you sometimes get the result you're after. That is what I would call variable reward. If you do social experiments, folks tend to love that variable reward. If you give a rat a button and you sometimes give them a bit of food, it just keeps pressing that button every day. But that's not really solving a problem for you as much as it is giving you a different problem to contend with. So while that's a proven business model, it's definitely not something that you want to productionize in this case. Now, we saw some variable responses getting back, and we can tweak them a bit by being very clear in our instructions. We just gave it a one-line instruction, like make the default case the last one. Whereas if we add more to it, like do not change the order of the other case statements or keep the logic the same, then it might do a bit better, but it's not suddenly going to be predictable. Because, like I said, the cases where it shouldn't have done anything at all, it still starts to do changes there. So if you're going to run this repeatedly, you're going to have a large problem. So this is kind of like where I said earlier, our customers expect things to just work. Clearly, this doesn't really work well for them. So we are going through that trough disillusionment for the technology that we're using here. There's a lot of promise, but it doesn't really materialize just yet. So we set out to look for a better problem to attack with this same technology, because we still want to leverage this. We think there's promise, but we wanted to figure out where it would fit in well. And for us, that meant looking at the better search, because we had a somewhat crappy search. It was based on an old Lucene. We are mostly a Java shop, so this was, for us at the time, a logical choice to use. But it also had some limitations, because there wasn't any support for word stemming, which meant that sometimes you wouldn't find the recipe you're looking for because you're using the wrong word to find it. Or worse still, that sometimes led to folks re-implementing a recipe we already have, but naming it slightly different. You can have like change dependency, bump dependency, upgrade dependency, upgrade dependency, migrate dependency. All of those at some variation existed for you just to change the version number of a dependency. Now we could have spent a lot of time tweaking Lucene or looking for the newer versions that are out there, but it's really, it's a bit of a lost cause because it's just not perfect in what we need there. So instead we looked to see how we can actually implement this using some AI. So we did some very naive attempts at first, where we just took an out-of-the-box model. We said, well, here's a query that our user is looking for, and then here's 1,000 recipes that we have. Please pick the right one. And that didn't quite work well, because what we found is that if you give it that amount of text, it's just going to get lost. It's not going to find the thing that you're looking for. It's going to lose attention. And even worse, at some cases, it started to invent new recipes, which isn't great if you want to have a search that you get back something that doesn't exist. It does great wonders for your perceived coverage of recipes that you have, but it doesn't really help your customers achieve the things that they're after. So then we kind of figured out like what is a better way to actually implement that. And for that, we look towards retrieval augmented generation. So in this case, you would, like I said previously, we might have mismatches. Here we take the query that you hand in, we turn that into a float vector, and then that ends up at some point somewhere in a space. And then you look for elements that are close to it in space. So that also has some consequences where if you think of words that might seem like opposites, like love and hate, those you wouldn't necessarily expect those to be very close together, but they're both very strong, passionate emotions, which actually means that they are then close in that search space that you're after. So if you look at distance there, then you're gonna find those, even though they might be slightly different in the meaning to us. So with this, we got some first results, and then we started to validate those results. So we had a couple of search queries, we had the expected hit that it should be finding, and it turns out that we got 1 out of every 20 correct, which again, for search isn't great. You're finding the one thing that you're looking for once every 5% of the cases. So that was actually quite terrible. This was kind of the low point that we had in our looking at AI as something usable for our customers. So Justine then went over to her colleagues at the Mila Institute to ask, like, what's going on here? Why can't we find the thing we're looking for? And it turns out that we were using these models incorrectly. So you can't really use these embeddings unless they are trained for retrieval. And this is why it's been great to have Justine at the Mila Institute, because we can use the collective knowledge to help shape the solutions that we use at Moderne, and then instead came up with this approach, where we take your input query, we turn it into that float vector, we look for things at a certain distance from that vector, we take the top, say, 20, 25 of those, and then we do some re-ranking, seeing which of those are actually close to what we need. And then from there, that filters out the ones that are not a good match for the technology that we have. And then finally, they do one last step to sort them based on how many composite recipes are in there to better match with what our customers are looking for. Now, we looked through a lot of models we could be using for each of these steps, and they're very wildly differing characteristics. What we recommend if you want to do something for yourself is to look to the, for us, massive text embedding benchmark to see which of the models that are out there are going to be a good match for you in terms of what you need for performance, runtime requirements. And then for us, that meant that we're now using a model that is fallen out of this top 10 since, but it does work quite well for our use cases. And then has the desirable characteristics of decent performance and low requirements. Now, if you want to know more about this approach, then I recommend that you read this blog post, because I don't want to go full in depth here. Like I said, the best content is near the end. But I do want to show you a brief demo of how this actually now works, because there's been a lot of effort put into this. And then I would want to briefly show you how we can now use this when our customers are looking for recipes in a builder that we have. So we have here the Moderne Marketplace. Let me do them full screen. You can see we have a couple hundred use cases for C#, TypeScript, Java, and other technologies in here still. But most interestingly, if you go to the recipe builder, we allow you to compose recipes together. So let me reset this one briefly. Here you can actually search for recipes, and like I said, we have recipes to change classes, change types, change method arguments, things like that. All of them, the typical changes that you would expect to see in a larger migration. So if I here search for rename a Java type, then I would expect to find the recipe that we have specifically for that. And you can find here that indeed the change type recipe, which has no link to rename, actually does show up near the top. We can add it. It'll ask me for some inputs. I'll say I want to change from string utils to some internal string utils. And then suddenly we have a first recipe with your own unique migration from something from Spring to something you have internally. Now you can probably think, well, how can we compose your own internal migrations that you have in much the same way? And like I said, what we're very pleased with here is that the search here is very quick. You're able to find things rapidly, you find things even if you use the wrong terms. And then this is where we have to also build in a button that makes Justine very sad. Because if you are working at a big bank and you don't like AI, then we have a button for you to disable all AI searches. And now if you do search, you get a much more mediocre result, and you won't find that rename type anymore. So this is always that duality with what we build with AI, that you now can't find the recipe that you're after, but you are fully compliant with your internal policies. It's a bit of a shame, but we've made it work just because we had to. So with that, let's switch back to presentation. Like I said, if you want to read more, then go there. And then with the builder, that's where you can compose your recipes in this way. But much rather than giving you search, where you need to know what you're looking for, we would much rather give you recommendations. And this is another use case that we explored, where we are able to want to recommend things for you to run. And this we played around a bit, where we use generative AI, where we give a snippet of your code and this prompt to say, well, find me something useful to do. So we played around with it a bit, and this was an initial prompt that we used, like you are a software engineer, what can you improve about this code? And then a snippet of your code. But we found one very simple way to make this a whole lot better. And that is by faking it till you make it. If you add senior, you get a lot better results. It's, playing around with this technology, I can really recommend. It does give you very surprising results once in a while. So now you are a senior developer. You're going to get a bit of code like we have here on the left. You pass it into an LLM, you give the prompt, and then you get back something on the right here. Now, I realize not all of you are fluent in Java, probably, but the recommendation here is to upgrade to Java 8 or later, because the Boolean class was deprecated. That is a load of crap. That's very much not true. But what is very interesting is if you take this bit of text that was generated and you throw it into our search, then it does cluster together very nicely with the recipes that we have in there. So we're reusing that search capability that we built initially. Then we get this generated bit of text, you get that embedding, and you find the recipe that you're after. And that will probably apply quite well to the block of text that you have on the left to give you meaningful transformations on your code. So that looks good, but then nothing is ever easy when you run at scale. So this is the type of scale that we see quite often with our customers. So you'll have some 1,200 repositories. We have customers with quite literally 200,000 Git repositories that they maintain through this platform. And then they want to look across all of that and get recommendations for their code. So say that we have some 400,000 method declarations in here, and we want to get some recommendations, and say that that chain of having a generative AI plus a search model takes about 3 seconds to do so, then this would be 2 weeks of work to get some recommendations for you to run things on your code. That is pretty terrible, because even if you, through some heroics, are able to speed this up by 50%, you're still going to have to wait a week to get some answers here. So then we went back to embeddings. So we previously used embeddings for our recipes, but now we figured we can also do embeddings for your methods. So when we take a method declaration that you have, we can cluster that together with some other method declarations that you have, and figure out which of those are going to be very similar to others. And through these clusters, we then take representative samples and only pass those samples into that recommendation flow that we have. Because this way we kind of generalize that if you have methods that cluster together very close together, then any recommended recipe on that sample is going to do improvements for the whole cluster. So that flow then gives us a way to run at scale for something using meaningful sampling to do recommendations for things for you to improve on your code just using this flow. Now, again, if you want to read more, there's a whole blog that goes in much more detail than I'll cover here. But I want to cover a few more use cases still. And one of them is a typical customer use case that ended up with us because it helped shape the approach that we landed on with AI. Now, we had a customer who was using a particular identity access management provider, and it was integrated all over the place because it is access. You're going to have to do that for every service that they had. And then, of course, that vendor thought, well, now that we have them, we're going to triple your costs in 3 months out. So if you want to stay with us, then you're going to have to pay a lot more. Whereas our customer thought, well, I kind of really like to get rid of them because we don't know if we're going to triple it again next year. So they came to us with, how are we using this particular vendor? Now that is something that is very easy to formulate, but it's very hard to ask a bit of code like to get an answer based on that. And worse still is that they, what they found is that every integration with that vendor was using a particular HTTP header, where you think, oh, good, I only have to find all the places where I'm passing that header along into an HTTP client. And then it turns out that they were using at least 5, 6, 7 different HTTP clients that they knew of, and probably a lot more that they didn't know of still. So we really wanted to find a way for them to find each instance where they might be using that particular HTTP header to integrate with that vendor, and then get rid of that if they could. So we used, again, some embeddings to try to find this, but this is a different problem than we saw previously, because previously we were able to use sampling in those clusters. But when you're doing a search, you can't really sample, because if you're going to sample, that also means that you're going to leave out things. And if you leave out things in search, you're not going to find the thing that you're after. So again, same math problem applies as well. Like even if we look not just at the method invocations, but also just the method declarations, the signatures that are attached there, that means that we're going to have to wait, in this case, I think 10 hours to get some results of a search security that you're doing. That, while neat, is not going to help you very much if you have these types of questions more often. So then what we ended up doing, and then there's going to be a link to a blog that explains this in more detail, is that we started to look for the signatures of all the methods that were being used. And then from there, did a analysis to cluster those based on their description, the Java doc associated with those methods. And then we tried to look for the top 500 methods that most closely resembled that query that we have. Is this an HTTP client using this particular HTTP header that is passed in? And then from there, try to find the ones that we're interested in. Now, in this case, we ended up with a chain of models, each with different characteristics. The first one is a very simple one that has a clear yes or no on is this related, or I don't know, and then you hand it off to the next one, which is slightly more complex, different characteristics, but that also means that it's already searching on a smaller set. And then a final one that also gives a yes or no, or I don't know. And then in this way, we have those chain models to be able to find those exact method invocations of libraries that they didn't even know they were using for that particular HTTP header, to be able to, in the end, phase out that vendor before that 3-month block. And they were quite pleased with that, because if you're able to have that flexibility in what technology you're using today versus tomorrow, then that's going to help you, have some leverage over those vendors. Say that I'm going to switch to something else if you don't want to play ball in this case. But it also meant that it was a realization for us, because these types of questions, they have those quite often. They'll come to us, and initially we would see them as like a one-off project for them to do. But then in the end, every time it was a unique use case, and quite often they actually wanted to ask those questions in natural language. And so what we ended up doing is we wanted to write an AI assistant that helped guide folks to what we have available in the recipe catalog. And now with some 4,200 recipes, there was a lot of questions like, do you have a recipe for X, or how can I best do Y? And while we were already used to getting those questions from customers, quite increasingly we also were getting those questions from new employees. We're a growing company, and I think as part of that, you get a lot of these, I don't know this, let's ask someone who does know, and we called that system the Just Ask Tim. But it didn't really scale well, because it went down every night, and sometimes even a whole weekend. And that just meant that we needed something different to actually be able to service these types of requests. So we set out to create an AI assistant that leverages last year's MCP edition of tool calling models. Because what we found, initially we spent a lot of time selecting the best model or even trying to train our own models. These days, with MCP and tool calling, we found that models are very much commoditized. There's little sense in training your own model and maybe get it wrong. You actually want to try to use an out-of-the-box model to do exactly what you have. By giving it better data and better tools, you can achieve better results without any of the hallucinations that plagued the approaches we used before. So this is then the flow that we developed. You'll see from the top left, you'll have a user that asks something like, how is Guava used? And then we have our LLM, which translates that into, well, I know a tool, and that tool is called the search for a recipe. And that is then just the block that we developed at the start. And that one, you can then ask more details about, like what are the options for this recipe, and then it gives you those options, and it runs the recipe, and then it gets back, and then based on the output data table, you'll formulate a response and give you a nice summary of how this is actually used. And this, to us, is very much a flow that I was doing like for customers and educating them on, but now we actually have a bot to do this type of work. Because exposing a tool to your model, or any model, has become very easy to do. Here you can see a bit of how we've done that. There's just a bit of description, and then there's 2 annotations, one for LangChain, one for Quarkus. Just doesn't really matter much. We saw an earlier example today with using Python. But very much that description of, here's a tool, and then you just run a bit of code you had anyway, because we had that code to do that search. And now it's actually being invoked by an agent that does all of that. So, and then the neat thing for us is we have 5 or 6 different tools. Like I said, search for a recipe, describe a recipe's options, run a recipe, and analyze a data table that comes out of the search that you do. Now that data table is something is very tabular data, which we developed before we envisioned using this for AI. But we found that it is a very good match for AI, because they love having that type of data to go over, make summarizations, visualizations, that type of thing. So with that, let's see a very brief demo of how this actually works. And let me try to switch screens again. Come on. It all goes well. Yep. Now this one is available on moderne.io/chat. If I were typing that correctly. This is exactly what you get here. So you can ask, we've pre-populated a number of questions you could ask, but they're not pre-scripted. So if I click on one of these, it's just going to figure out the way how to actually invoke these types of search for a matching recipe, and then it will take you through the steps that it's doing here. So in this case, it used the search that we have to find a number of recipes that could be related to what we're doing for. And then it's going to run the description of those recipes to figure out how it should actually invoke them. And then actually run those recipes. And in this case, we're running not against a single project, but a dozen or a couple dozen. And then from there, you'll find that we get that summary of data of how things are being used. Now, in this case, there's always a bit of awkward silence where you have to wait a bit for things to complete. But it's having a way for you to define how to ask questions and find those recipes, run those recipes, and do that pretty much autonomously has been a game changer for us. So we have a lot of sales folks at the company as well. They might send you an email once in a while, apologies. But they had a field day the moment that we got this tool out internally, because suddenly they could ask a lot of questions that they used to ask some of us. So even could ask questions that they were embarrassed to ask still after being with the company for a year. And then they get an AI that is able to autonomously answer those questions and give you very good results here. Now, of course, demo effect, it's taking slightly longer than I would have hoped. But what you can see here is that the find methods, it actually figured out the arguments to pass in here to say, well, this is like an AspectJ type of string where you say, I want to find methods in this package, and then it can be any method name and any method number of arguments. And then when you get a result here, try to see if the next tab, like what it's waiting on. We can already explore some of the results that you get here. And this is where you can see that there is value in having a deep type information about the elements that we have in our model. So when I told you that we enrich that model, here is where you can see that's necessary, because if you just have the text of this string, you have no indication that it is coming from Apache Commons. It can be any number of libraries that have this exact same method name, but by having that defined right here, you can see all of these results. Now, let me try to see which one is the straggler. Doxia, and Springbond. That's a bit unfortunate. We can get back to it to see if it actually completes. But what it actually then allows you to do, let me try this. Let's see if I can kill it. Does that work? Oh, it's actually done now. Fine, great. So here you can see that it's actually completed, and then, no. This is an older run I did. So here we have that same run we did. We found the message usages, and then we get this summary based on the data table produced from the find recipe that we ran. So it found all the individual methods that we ran. It grouped them into different technologies that were being used. And like I said, very much not scripted in any way. It's just tools discovered, run, and then analyzed by an AI model. And then it asked me some questions, and I deliberately asked a bit vaguely, like, yes, I would love more details. And then it asked, okay, which details then? And then, yeah, AI operations, number 4. And then it, again, uses that tabular data that comes back for you to be able to make sense of all of this. And then further on, we can even ask it to, I think I had an example earlier today, where I asked it to create a histogram, as you saw earlier today. All of that is possible just by having a tool like this to be able to run an analysis of something you just thought of, and then a histogram, and then using that data in this type of way. It's not sure if it's going to do what I was thinking. So let me switch back to the slides and then see from there. Come on. So, like I said, our customers, they were very much pleased to be able to have this type of way to now interact with the code that they have, and on a large scale ask these type of questions that we previously had as a one-off, but now they can actually do this themselves. But of course, being our customers, that also meant there's some complications here as well, because we can't really use any of the fancy Anthropic kind of models here. So we really had to support the bring your own model as well. Because our customers, they want to have full control, they maybe want to have some in-house models instead that we're using, and that kind of complicates our deployment models as well. So what we've had to do is take this web interface, wrap into a desktop client that you can also run on your own machine, and that then also allows you to integrate that with other NCP servers and clients like Claude to be able to ask questions of your code and do integrations in that way. We have some really nice demos together with the folks at JetBrains, integrating this with their IDE in this way. And that has been a great boost to finding out how things are used and what you might want to be changing instead. And that then brings us to like full circle. Back to, like I said, initially we wanted to generate recipes. And of course, we've kept tabs over the year and a half or so that we've looked into this. And we've seen big improvements and investments in the new code authorship sessions. So where previously we saw very bad results when generating a recipe, these days we can actually hand off a migration guide from a wiki or a README that just as it's published as a blog, and then get a very decent pass at recipes generated for you. So this is, we did some tests with Juni, works quite well in our case, but we also had to make some adjustments. So what we've ended up doing is change our APIs to be more accommodating of what these tools support. So we had 1 minute left. We had an API mostly geared towards Java, but we found these tools are better able to write recipes in TypeScript and JavaScript. So instead, we've made it able to write those recipes natively in those languages as well. So now that you can write a recipe inline, run it, and then have that generated in that way. But you don't want to miscontribute any qualities from the recipe authoring experience, because we have found that it doesn't translate very well to the recipe maintenance or code maintenance workflow that you have, because it's very easy to have a limited window, generate some code, and go from there. It's very hard to take a couple million lines of code and do reliable code changes there. So you really want to use informed code changes from a recipe output using data tables, things like that, to make rules-based code changes. And with that, do your code changes. So that has been my presentation. If you want to learn more, have a look at these links. And with that, I thank you very much for your attention.